KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hi students, now we are going to start a new chapter. So last chapter is work power energy. After completion of that, we should start new chapter, that is system of particles and rotational motion. Okay, so from today onwards, one by one we will finish this chapter. Okay, see here, system of particles and rotational motion. Okay, right. So in our first year syllabus, right, so mostly our concentration is mechanics, right. So mechanics means which is an important and oldest branch of physics, where we are going to discuss about motion and its effects, right. So in mechanics, most important concentration, that is what we concentrated mostly on types of motion and types of motion, right. So out of all those types of motion, one of the important motion, that is what type of motion, is rotational motion. Okay, right. So here, in case of rotational motion, before going to understand what is rotational motion and how a body is going to move in rotational motion, and what are the things which makes a body to get into the rotational motion, and before going to all those details, first we have to understand the condition, how it is possible to provide rotational motion to a particular body or an object, right. That is important. So that's why first we are going to talk about a massive body, right. So generally mass means a certain amount of matter, whether it is small or big, that doesn't matter, but we have to consider it as a massive particle, right. Suppose if the body is heavier in mass, means we can say that more number of particles are present in that particular body, right. So whether it is a single particle or combination of particles, it is referred to be having certain amount of mass. Okay, right. So in our earlier chapters, so what we discussed, we primarily considered the motion of a single particle. For example, if you see that chapter, that is what motion in a straight line, right. So there we spoke many things about a particle, that is what many things about a body. So wherever it is, whatever the situation, we talked about a body is moving, right. So the velocity of an object means there our imagination, and we consider that the whole body as like a single particle, So by assuming that, by considering that the whole body as a single particle, we discuss the entire thing what we happened till now. Okay, right. So we applied the results of our study even to the motion of bodies of finite size, right. We applied the results of our study even to the motion of bodies of finite size, assuming that motion of such bodies can be described in terms of motion of the particles, right. So assuming that motion of such bodies can be described in terms of the motion of such particle, okay, right. Any real body which we encounter in our daily life has a finite size. For example, a glass. So generally we used to take water with a glass, no? So a glass. Otherwise a mug, okay? Otherwise a water bottle. Otherwise a book, okay? Because as a student life, as a teacher life, right? Generally we come across our daily life most of the time with books. Similarly a duster. So whatever it may be here, any real body which we encounter in our daily life has a finite size, okay? Right. In dealing with the motion of extended bodies, that is the bodies with finite size, we often, the idealized model of a particle is inadequate. So when you suppose, for example, if you talk about the motion of particle, okay, so till now our discussion is like that only. The whole body we assumed as a single particles, and we discussed the motion, we discussed the position, right? We discussed the displacement, right? We discussed the velocity, acceleration, momentum, right? Force, etc. But here what he is saying is, in dealing with the motion of extended bodies, that is what finite sized bodies, right? The idealized model of a particle is inadequate, is insufficient, okay? Right. In this chapter, that is what system of particles and rotational motion chapter, we shall try to go beyond this inadequacy, right? So we shall attempt to build an understanding of the motion of extended bodies. We are going to understand the motion of the extended bodies, means the bodies of finite size, okay? Right. An extended body in the first place, is a system of particles. For example, if you take for example, a small piece of stone, otherwise a small piece of wood, otherwise you take the general thing, that is what eraser, what we rub the information what we have written with pencil, okay? So there itself, whatever it may be, which is the combination of particles, right? So when it is the combination of particles, so this is the sentence you have to say, that is what an extended body in the first place is a system of particles, okay? Right. So we shall begin our discussion, with the consideration of motion of the system as a whole, right? So here system means group of particles, right? So if you talk about one body, then which is a system of particles? Sometimes you can talk about 2-3 bodies present in one system, right? A system means a collective of, a group of. Even though if you take a single body, which is also a system of particles, okay? Right. So we shall begin with the consideration of motion of the system as a whole, right? The center of mass of the system of particles will be a key concept here. The center of mass of a system of particles will be a key concept here, okay? Right. So I used a new word, that is what center of mass, right? So what is meant by center of mass? You know, for example, a car, for example, a bus, right? An aeroplane. At the same time, if you go for train, see, if you compare all these things, the train is bigger one, no? So which is heavier in mass, no? So when we talk about the displacement of the train, what is the point we should consider? Do we need to consider the engine of the train? Do we need to consider the last compartment of the train? Do we need to consider the middle compartment of the train? So where should we consider? That is the thing, right? That's why not only train, not only bus, not only a human body, not only the body of a snake. So whether it is living or non-living, it doesn't matter. But the entire mass of an object, whatever it may be the body, the entire mass of an object supposed to concentrate at one point. The entire mass of an object supposed to concentrate at one imaginary point. At one imaginary point. That point is said to be center of mass. That point is said to be center of mass. Okay, right. So now I will tell you the definition of center of mass. Till now I explained what is center of mass. Now I will tell you definition. Right. So center of mass is an imaginary point where the total mass of an object is supposed to concentrate. Center of mass is an imaginary point where the total mass of an object is supposed to concentrate. Okay, right. Suppose for example in our classroom, sometimes you are playing with the exam pad. So by concentrating at the middle of the pad with your forefinger and the pad you are going to rotate. So if you observe carefully, the point where you concentrated is almost at its center of mass, right? So for everything, when there is a mass, automatically there is a center of mass. Okay, but sometimes center of mass may be within the body, sometimes center of mass may be outside the body. For example, if you take the bangle, right? So for the bangle, the center of mass is outside the body because bangle is in circular shape, no? So there is some mass. So for that bangle, the center of mass is at its center, but at the center no mass. So in this example of bangle, center of mass is outside the body. For example, if you take a pencil eraser, in that case center of mass is within the body. Okay, but in the case of pencil eraser, you cannot touch the point of center of mass. You cannot touch the center of mass because that is within the body. Even for human body also, there is center of mass, right? That is what in the middle of the body, but that you can't touch. Just you can imagine. You can imagine. Okay, right. So we shall discuss the motion of center of mass of system of particles and usefulness of this concept, right? What is the concept? Center of mass, right? So the discussion, that is what we shall discuss, the motion of center of mass of system of particles and the usefulness of this concept in understanding the motion of extended bodies. In understanding the motion of extended bodies. Okay, right. Next, ideally a rigid body is a body with a perfectly definite and unchanging shape, right? Ideally a rigid body is a body with a perfectly definite and unchanging shape, right? The distances between all pairs of particles, such a body do not change, right? So here he is talking about a rigid body, right? Rigid body, right? One thing is very important, ma. When you see different bodies in our daily life, for example, stone, for example, a duster, right? For example, a piece of wood, for example, a piece of iron. So what is the basic difference? I am not going to the composition of material, just I am talking about its strength of the body. You know, a piece of steel you can't bend it, but if you take the duster you can bend it, right? It can easily change its shape, right? But whereas if you go for a piece of iron, a piece of steel, a piece of stone, right? So in all these cases you cannot deform with your hands. So we can say that a stone is a rigid body when compared to the duster, right? So similarly a steel, whatever it may be. So here through the comparison only we will decide which is a rigid body and which is very strong when compared to the other, right? So that's why we cannot say that this is the perfectly rigid body, right? So that is not possible to say. But through the comparison we will decide what is a rigid body. What is a rigid body? And here he is saying the important information about rigid body. That is what a rigid body is a body with a perfectly definite and unchanging shape. Okay, right. And one more point is the distances between all pairs of particles of such a body do not change. The distances between all pairs of particles of such a body do not change. Okay, that is what, this is the information about rigid body. This is that is what the nature and what is the size, okay, and the behavior of a rigid body. Behavior of a rigid body, right? Truly, no real rigid body exists, right? So, real bodies deform under the influence of forces, but in many situations, the deformations are negligible, right? In a number of situations involving bodies such as wheel and tops, steel beams, okay, molecules and planets, right? On the other hand, we can ignore that they wrap, bend or vibrate and treat them as rigid. Okay, so from starting of this class up to here, so till now what I am saying, our concentration is about a body, right? So before the starting of this chapter, we consider the whole body as a single particle. But in this chapter, we are going to discuss in deep, right? So there itself, our concentration is a body with finite size. Okay, so when we consider a body with finite size, we have to talk about the center of mass, and then we also need to talk about the strength of a body, right? So center of mass is an imaginary point where the total mass of an object or a body supposed to concentrate, right? Next, rigid body means a body which is with a perfectly definite and unchanging shape. That is one thing. And the distances between all pairs of particles of such a body do not change. Okay, right. Next, what kind of motion can a rigid body have? What kind of motion can a rigid body have? Okay, see this. So here we are going to take many examples, right? That is what here it is what rectangular block, right? It is like what a circular, right? Otherwise here you can imagine that is what a spherical, right? And it is what a fan, it is what a top, right? It is what a pot wheel, right? It is what a table fan, right? So whatever it may be, here we have many examples. We are going to discuss about the motion of different examples. First, you consider a rectangular black sliding down inclined plane without any sidewise movement. Just we kept there and it is coming down without any sidewise movement. So here this block is said to be in translational motion, right? If you see the points like P1 or P2 of the block moves with the same velocity at any instant of time. So that the block is said to be in pure translational motion. Okay, so when the body is moving down the plane, all the particles of the body are moving together. They have the same velocity at any instant of time. Okay, the rigid body here is in pure translational motion. So here this body is said to be in pure translational motion. Okay, right. And see this statement, in pure translational motion at any instant of time, all particles of the body have the same velocity. In pure translational motion at any instant of time, all particles of the body have the same velocity. Okay, right. And you see this example here, it is what rolling motion of a cylinder. It is not pure translatory motion. If you see the points P1, P2, P3 and P4, okay, if you see all these points having different velocities, right? these points having different velocities, and with these arrows you can see the direction of velocity at that particular point. You can see the direction of velocity, right? And P3 is 0. So the velocity of a point P3 is 0 at any instant. At any instant, and moreover, the cylinder is completely in rolling motion without slipping. So if the cylinder is slipping means this P3 will not change. If the cylinder is rolling means, right, so this spot will come here and this spot will come here, and it will be like this, right? So it comes to reach the ground. See here. So in case of this body, that is what pure rolling motion, right, of a solid metallic or a wooden cylinder down the inclined plane, okay. So the rigid body in this problem, namely the cylinder, shifts from the top to the bottom of the inclined plane, and it has translational motion, okay. This is what this is the picture, right? So where it has, if you consider rolling motion of a solid cylinder down the same inclined plane, okay, and the rigid body in this problem, namely the cylinder, shifts from the top to the bottom of the inclined plane, and thus it has translational motion. So all its particles are not moving with the same velocity at any instant. Therefore, it is not in pure translational. Its motion is translational plus something else. Okay. So you just compare these two pictures, ma. It is in pure translational motion. Okay. But here, if you observe carefully, just now I told you it is in pure rolling motion. Now I am saying to think what will happen. What is there more than that? Why? Because if you see this body only, which is moving like this, but if you see the whole body on the inclined plane, it is coming from there to here. Right? So there is rolling motion, no doubt at all. But more than that rolling motion, something is there. So what is that something? In order to understand what is this something, right, we are going to take a rigid body, right, and it is going to, right, it cannot have translatory motion. Okay, right. So the most common way to constrain a rigid body so that it does not have translational motion, right? The most common way to constrain a rigid body is so that it does not have translational motion is to fix it along a straight line. Fix it along a straight line. It is complex to understand, ma. So you please be concentrate seriously so that you can understand. If you see a bus tire when the bus is in motion, if you see a car tire when the car is in motion, so that is the combination of rolling motion and translational motion also, right? So in case of rigid body, it is what the most common way to constrain a rigid body so that it does not have translational motion. Here he is talking about rigid body, he is not talking about motion. Previously we talked about motion, okay, right? The only possible motion of such a rigid body is rotation. So what he is saying is, in case of rigid body, it doesn't have translational motion, so that it must have a pure rotation. It must have means what must have? A rigid body must have. A rigid body must have pure translational motion. Pure rotational motion, right? Okay. See this. So the line along which the body is fixed, is termed as axis of rotation. Here he started to explain about the rotational motion, and here itself he talked about what is the axis of rotation, right? So the line along which the body is fixed is termed as its axis of rotation. rotation. Okay, right. And you may notice that, right, here itself you may notice that in rotation of a rigid body about a fixed axis, in rotation of a rigid body about a fixed axis, every particle of the body moves in a circle. Every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis, right? For example, you take the fan, right? You take the fan. So in this case, 3 wings are there. Just let us imagine 3 wings are there, and it is the axis of rotation. See the red light now. It is the axis of rotation, and if the fan is rotating like this, means every particle of the fan is in circular motion about an axis. That is what axis of rotation. That is what axis of rotation. Not only fan, we have many examples. Suppose you see this, that is what a potter's wheel, right? Here this is the axis of rotation. If you observe carefully, this whole pot is in rotation in this direction, right? So when the potter's wheel is in rotational motion, every particle on the pot is in rotational motion. The distance of the particle from axis of rotation may be different, but every particle on the pot is in rotational motion. And moreover, you have to say that every particle is in circular motion. Every particle is in circular motion around axis of rotation. Okay, so this class is very important for us, because the rotational motion we are going to the rotational motion we started to discuss, and here itself we have to understand, if you consider the body as a particle, what happened? If you want to consider the body as a body, what should we learn? That is what we have to understand the concept of rigid body, and then you have to understand what is pure translational motion, and then you have to understand the combination of rolling motion plus translational motion, right? Afterwards, you have to understand what is axis of rotation and what is the difference between circular motion and rotational motion. Circular motion and rotational motion. Okay. So here, suppose if you take another example, that is what a spinning top and what is that oscillating table fan. Oscillating table fan, right? So if you take the oscillating table fan as an example, here the point O is fixed. The point O is fixed, but these 3 wings are going to rotate, will be in motion without changing the position completely from one point to another point. Okay, so that is what he is saying. Here you can also see this picture, right? So this picture is talking about rotation of a rigid body about z axis. It is x axis, it is y axis, and it is what z axis, right? So you can see the points P1, right, and P2. The distance of P1 from axis of rotation is R1, and the distance of point P2 from axis of rotation is R2. Okay, and this is the point of P3. P3 is not in motion, right? It is what the velocity of the point P3 is 0, but P1 and P2 are in motion, right? So that what you can, this is what C1 and it is what C2. Okay, so like that you can represent that graphically what is the rotational motion of a rigid body. Okay, right. Next, you can also see another example, which is what see this, the difference between pure translational motion, right, and combination of translational and rotation. See here, so which is what motion of a rigid body. See this, see the position, right? So here there is no change in the position, right? So it is the one, it is the axis, and it is the axis. This is what central axis of your body. There is no change in the position of central axis of your body. So which is the example of this body in pure translational. Pure translational. Okay, right? Pure translation. And if you see here, which is what, see the difference between these two pictures, right? So which is one and which is the second, and this is the different instant of time. Different instant of time, right? So here, that is the turning will be there, no? The body is going to tilt, See here again it is going to tilt, right? So this is a combination of, this is the combination of translation and rotational motion, right? So by seeing these two pictures, you can understand easily, right? You can try to do this also just by taking, that is what a bottle, that is water bottle, right? So you can do this, right? So when a body is moving like this, you can try to understand the difference between translational motion, pure translational motion, and this is the combination of translational motion and rotational motion, that you can understand clearly. Okay, right. At last I want to say some of the information. See here, the motion of a rigid body which is not provided or fixed, the motion of a rigid body which is not pivoted, okay, right, which is not pivoted and which is not pivoted or fixed, okay, which is not pivoted or fixed in some way, right, is either a pure translational or in some way is either pure translational or a combination of translational and rotational, okay. And the motion of a rigid body which is pivoted or fixed in some way is rotation, right. So here he is not going to fix or pivoted, but here it is going to fix. So in case of fixing it is rotation, but in case of not fixing it is the combination of either pure translational, here it is pure translation, but it is the combination of pure translational and rotation, okay, right. So in this class we concentrate to discuss, we started a new chapter, that is systems of particles and rotational motion. Here we discussed, if we consider the body as a whole body, what we should discuss. One thing is the idea of center of mass, another one is the discussion about rigid body. Next we discussed about pure translational motion and the combination of rolling motion and translational motion, and then we started to discuss about circular motion and rotational motion, right, and finally the combination of rotational motion and the combination of rotational motion and translational motion. Here it is only translational motion. Meanwhile we have given some of the important definitions, that is for center of mass and what is meant by rigid body, right, and what is meant by rotational motion, okay, right. We will continue in the next class. Thank you.